Every soil moisture sensor I've used always felt like an afterthought, something you just stick into a plant and forget about. I wanted to fix that, and after 2 attempts at making a probe-style monitor, I think I finally did. Well, almost. While my first 2 designs worked, their large form factor made them quite awkward when placed on smaller plants. So after getting a recommendation from one of you guys, I set out to make an all-in-one solution integrated inside a pot. The pot can be separated into 3 main modules: the electronics housing, the plant housing, and the outer lid. Inside the electronics housing will live the main PCB along with the motion sensor and battery. Attached to the top will be the plant housing, which will incorporate a solar panel that will be flush with the pot's edges, along with a cut to easily plug in the soil moisture probe. Lastly, the outer shell will slide on top to hide the screws and also give the pot a more finished look. I first began with the most important part of the build, the electronics. Here, I had a few criteria that I needed to fulfill. First, it had to be as hassle-free as possible. The most logical answer to this was to have a solar panel, which could use the indoor light in my room to slowly recharge the battery and keep the sensors running during the night. The second criteria was to somehow display the plant's status so that I knew when I should water it or not. Since I don't like to always check my phone, I decided to go with some LEDs that would change color depending on the level of moisture. However, after doing some calculations, I quickly realized that having the LEDs always on would not be possible, since they would draw way too much power, resulting in the battery dying just after a few hours. As a workaround, I came up with the idea of using a motion sensor to trigger the LEDs only when I would be inside my room. Once I was settled on the parts, I went ahead and designed the PCB and sent it off to this video sponsor, PCBWay. PCBWay is an easy-to-use, trusted, and affordable PCB manufacturer. Using their online tool, you can easily upload your Gerber files and choose from a variety of materials and finishes for your PCB to suit your own design. Alongside PCB manufacturing, they also offer PCB assembly, CNC machining, and 3D printing. Check out the link below to learn more about PCBWay. When the PCB arrived, I was very impressed with the quality. I was also a little bit nervous by its complexity, since this was my first time doing SMD soldering. I decided to assemble it using a heat plate and some solder paste, which worked great with the stencil that came with the PCB. However, there were plenty of minor issues with the design that I wish I knew about before ordering the board. For one, I completely underestimated the size of an 0402 LED, which was so tiny and way smaller than an 0402 resistor or capacitor that it wasn't even funny. Same went for some of the diodes, which were literally smaller than a grain of sand. I also regretted making the solder pads so small, since it took an extra amount of effort to ensure that the wires would not short one another. Nevertheless, after lots of frustration and patience, I eventually finished the PCB, which to my surprise didn't short circuit once I plugged it in. However, as I later found out, this didn't mean that everything worked as intended. Originally, I planned on using ESP Home for the firmware, which would let me easily view the sensor data on my phone. But no matter what I did, I couldn't get it installed on the chip. After wasting many hours on troubleshooting the installer and even trying alternative firmware like Tasmota, I simply gave up. Unsure why this was the case, I ditched the Wi-Fi and settled on just using the LED-based indicator system. Afterwards, I 3D printed the parts, choosing to make the bottom section two-toned to make the design more interesting. Once the rest of the parts were all printed, I slid the PCB in and attached the motion sensor with a little bit of glue. I then stuck the LED strip on the inside wall using the adhesive on the back. Afterwards, I put the solar panel and moisture sensor into the top section, attached the wires, and screwed it shut with some M3 bolts. Unfortunately though, the top part of the pot was way too tight, and being too lazy to reprint it, I decided to just sand off the excess until it fit into place. And with that, the build was finally complete. But would it work? To test it out, I placed one of my plants into the pot and added some water. And to my surprise, after triggering the motion sensor, the LEDs changed color, which meant that the soil moisture level was now in the optimal spot. Since I couldn't check if the Lipo charger was on from the outside, I took the pot back apart and put it in some sunlight. The glowing blue LED on the PCB meant that the Lipo was successfully charging from the solar panel. While the device for the most part works as intended, this being the first version, I naturally ran into some issues. Remember how I wanted to add Wi-Fi functionality to view the sensors through Home Assistant? Well, unfortunately, with the current design, this isn't possible. Basically, the chip needs more power than I gave it. The issue is that the voltage regulator I picked has a 250 milliamp current limit, which is just not enough for when the ESP32 is connecting to a Wi-Fi network. The next issue is the solar charging system. Although the TP4056 based charging system works, the maximum current from the solar panel is only 60 milliamps, which means that to charge the battery, you need around 11 hours of direct sunlight. However, the way that the 5-volt boost converter for the LEDs is designed, it's always running in the background, even when the ESP32 is in deep sleep, which results in a lot of wasted energy and makes the charging time much longer than it needs to be. Despite these issues, I'm pretty happy with the result, especially considering that this is only version 1. Stay tuned for my next video where I plan to fix all these issues and add even more features like better smart home support, a more customizable design, and even better power efficiency. If you enjoyed this video, make sure to press the like button and I'll see you in the next one.